Alright, so here in this video I want to show you guys the construction of a motor starter and how to troubleshoot and make sure you have a good starter. First, let's take it apart. We have three different components here. The auxiliary needs to come off by pulling this tab towards the front, and you can slide it up, right? That takes that hammerhead off this plunger. Then you can just separate the overload relay from the contactor. So you just got to unscrew these three-phase screwed conductors here. It should pop right off. Okay. So now you have the three different parts of a motor starter, right? The contactor itself is just a high current electromagnetic switch. Then you have the overcurrent protection device, the overload. This protects the wires that are going to deliver energy to the motor and the motor's windings itself. This separates the job of the circuit breaker or fuse in the circuit, because the circuit breaker and the fuse in a motor starter circuit now only is for short circuit protection, and the overload is for overcurrent protection. Typically residential, commercial, things like that, in lighting, in heaters, the circuit breaker is the overcurrent and the short circuit protection. But in a motor control, motor distribution circuit, we do isolate the two things, where the overload is overcurrent protection and the circuit breaker or fuse is your short circuit protection. And then you have the auxiliary contact here. This is for latching, signal sending, some low power distribution, where the contactor is the high power distribution. So this guy's part of the power circuit, this guy's part of the power circuit, but this guy's part of the control circuit. All right. Now, let's go ahead and take apart the actual contactor itself, because a lot of the times it's just the coil that fails, or there's debris that gets stuck inside, right? You can see right here in this little opening, you can see the actuation of the contactor inside. So things can actually find their way in there and jam this thing up from not working. So in most motor starters, the instruction manual will tell you how to disassemble it, right? Take that latching off of this guy here. There's a couple of these pinch connectors here, and this opens up the motor starter to where we can see the internal workings. Okay. So in my hand in this hand is the coil itself. You can actually remove the coil from the body, right? This is like a, I don't know, $12 to $15 part, depending on what year it is now that you guys are watching. But this is usually the part that fails, and we can just replace it without replacing the whole motor starter body, overload, and all that stuff. Another thing that happens with excessive use and buildup is magnetic dust will start piling up on these two posts here, and that causes like a vibration or a humming when you energize your motor starter at times. So if you get intermittent humming, you might want to check the iron core of your motor starter and make sure that's clear of any type of magnetic debris. Right? The spring could also dislodge, come into problems. Right? So the spring is what keeps everything in a normal condition. And when you energize this coil, right, the coil creates a north and a south pole, and it'll energize the bottom magnetic iron core opposite of the other magnetic core, and they'll attract. And what that does is it operates this plunger, right? So when I'm going back and forth, that's the action side, and that's what actually pulls and opens and closes the contacts for your auxiliary. All right. But it's also closing and opening large contacts inside of the motor starter itself. So with all that put together, go ahead and put this thing back in position it was. Okay. Because now what I would do with a brand new motor starter is I'll check the resistance of its coil, and I would write it down and put it on the side of the motor starter itself. So put your meter to an ohm setting, go right across the A1 and A2 terminals and look for a resistance. This one's going to give us roughly 100 ohms. There we go, 96.8 ohms. So again, I would write that down somewhere in a note, anywhere where your preventive maintenance department would look for these things. So when you come back in a couple years, or maybe it's a different employee that comes back and you've dated and ohmed out the coil, now they might check it and see something different. Right? If they see 50, 60 ohms, now you know the coil is being shorted out and needs to be replaced. Or if you see no resistance, right? Open line, then you know that coil's open. But either way, you want to have a good marking of what that coil's resistance is, and every coil per manufacturer will have a different resistance. Most of them are roughly 100 ohms. So that's one good check you want to do before you install this, is make sure you have a certain resistance. And then your contactors, right? The contactors are the L1 to the T1 connectors. So what I'll do is I'll screw in my probes to the motor starter itself, especially on high current motor starters, because you want to make sure you have very good readings. So floating your leads across isn't the best idea. So you want to get a nice, good, permanent connection. And then what you would do is actuate the plunger with some type of force, right? And then your meter should show you 0 ohms. 0.1 is nice. 0.0 sometimes happens. But if you get any type of resistance, this is bad, right? 1 ohms, 2 ohms, 3 ohms, that's horrible, because when you send current through here, when it's closed and it has resistance, remember, current times resistance is voltage. So if you have 2 ohms of resistance here with 10 amps of current flow, right? 10 times 2 is going to be 20 volts. You're going to lose at this junction here, and it won't make it to your load. Your load will struggle to do its job and probably pull too much current, and then that's when the overload is going to trip. So always make sure you check for that. Never check for continuity. Always check for 0 resistance. I don't even have it on the continuity reading. It should be checking ohms only. Right? Another kind of preventive thing to do when you first install a motor starter is to check the resistance of the thermal overloads, right? Or the magnetic overloads of this guy, whether they're magnetic or thermal. These 3 posts up here, each one will connect to the corresponding post underneath. This is where the current flows to get to the motor, and this will gauge how much current's flowing based on heat. It turns the amperage into heat. So there will be some type of resistance from this post to this terminal, right? And I'm just going to show you, it's about 1 ohm. Right, 1.1 ohms there. This next terminal, we go to the next one. And it's going to show us about 1 ohm, excuse me. Got my meter jumping around place, but once we get a good connection, you'll see it goes down to 1 ohm. That's what these heater coils should be. So they'll produce heat, and we can adjust the amount of heat that makes this bithermal strip open the set of contacts that's going to your neutral. All right, so that's a good check to always do there. Never adjust your overload. Always do it per manufacturer's setting. And yeah, I hope this gives you guys a good understanding of how our motor starter works. Again, once everything's put back together, we can now say this is a good motor starter. And I would especially do this if I change manufacturers, right? Every manufacturer should have the same resistance, right? Part number, voltage, and everything. But if you give it different voltage, all those resistance of the coils are going to change. So thank you guys for watching. Make sure you turn your meter off, and I'll see you in another video.